Today we'll be looking at question number 1 from the AB exam 1998, and this is a calculator active question. I've classified it as a type 4 problem because it's got problem questions regarding area and volume. So let's go ahead and start with part A. Let R be the region bounded by the x-axis, the graph y equals square root of x, and the line x equals 4. So to start off, I'm going to sketch roughly what this diagram looks like. The square root of x looks like that. The line x equals 4 looks like that. And the x-axis is this region, or this line. So we've set up our region R, and they want us to find the area of this region. So area, we're going to take each of these little rectangles, which has a height of f of x, and we're going to multiply it by the width delta x, and that would be one rectangle. If we allow the delta x to shrink to a infinitely thin region of space, then the total area would be the integral of f of x dx, shrinking our delta x to the differential. And the start and end points of this area, we're starting our rectangles at 0 and stacking them up until we get to 4. Okay. Now, our f of x, we know, is the square root of x. So this is asking us to evaluate the definite integral of root x dx. This is a calculator active question, so doing this by hand opens up an opportunity for mistakes. So it's best on the AP test just to turn to a graphing calculator and evaluate this expression. So if we take our calculator here, clear off the screen, math 9 pulls up our definite integral, 0 to 4 of the square root of x dx. And we should get an answer. Looks like 5.3 repeating. If we want to convert that to fractions, 5 1/3, we would be good. So 5 1/3 is 16/3. All right, so the grading for part A is 2 points. You're going to get your first point if you have the integral expression that calculates area, and you'll get your second point if you were able to correctly evaluate that, either by hand or using a calculator. So, moving on to part B, they're saying find the value h such that the vertical line x equals h divides the region into two regions of equal area. So what they're doing is they're essentially creating a line at h so that the area on the left side of the line is equal to the area on the right side of the line. And we're not getting into the volume portion yet, we are just looking at area. So these two regions, the pink one and the purple one, we want to set that up. So in part B, it's a pretty straightforward problem. It's just another area calculation, and the pink region is the area from 0 to h of the curve, root x minus 0, or just root x. And then this has to be equal to area of the purple region, which starts at h and finishes at 4 for root x dx. And they ask us to find the value of h. So sometimes they just want us to set up the equation, and other times they want us to actually find the value of h. So here we're going to take the antiderivative and apply the fundamental theorem of calculus. So the antiderivative of the left-hand side is 2/3 x to the 3/2 from 0 to h, and this is going to be equal to the antiderivative of the right, which is the same value, 2/3 x to the 3/2, except this is being evaluated from h to 4. 2/3 h to the 3/2 minus 0 is equal to 2/3 4 to the 3/2 minus 2/3 h to the 3/2. And this is the equation that we're looking to solve for the value of h. Okay, so we'll start by simplifying this. 4 square rooted is 2. 2 to the 3rd power is 2, 4, 8. And then 8 times 2 is 16. So 16/3 is equal to, and then we'll add this to the right-hand side, 4/3 h to the 3/2. And then if I multiply both sides by 3, that will cancel the 3's. And if I divide both sides by 4, 16 over 4 is 4. So by multiplying by 3/4, we get h to the 3/2 is equal to 4. Finally, if we raise each side to the 2/3, that would cancel out the 3/2, and we get our value for h. This is the same thing as the cube root of 16, if you wanted to write it like that. 4 squared is 16, and we're going to take the cube root of that, which is definitely less than 4. So there's the solution to part B. The grading for part B, I have the key down here, equation in H and the answer. So setting up the equation in H is worth 1 point, and finding the answer is worth 1 point. Now, this is not the only approach. There's a slightly different approach that you could have taken. I won't work through the whole way, but if you set up your first integral for the region in pink, and you knew that this was half of the area, you could relate it to half of this number. So half of 16/3 is 16/6, and then you can solve that equation for h. It's another approach, but the difficulty or the problem with this approach is you're trusting that the answer you found in part A was the correct answer. All right, moving on to part C. Part C is a volume problem, and so we have the same region from the square root of x to 4, and we're going to take that region and rotate it around the x-axis. So this thing is spinning around this region. And what that's going to do is it's going to create kind of a mirror image of the function down below. The pencil needed to be sharpened. And this thing spins around the axis right there. So if we take one of our representative rectangles, we can say that the outer radius, the large radius, big R of x, is going to be root x minus 0. And then the inner radius, since there's no core being removed from this thing, the inner radius is 0 minus 0. And we get our two R values to plug into the volume equation. Now, if you're in my class and you've taken the notes on area and volume, we have this page where we broke down the type of volume problem that we're approaching here. The rotation line is below the region, and there's a loose sketch here. So we need the left bound and the right bound. Our rectangles are perpendicular to the rotation line, and we can see that the big radius is going to be the top function minus the rotation line, and the small radius is the bottom function minus the rotation line. In our case, the bottom function is just the line y equals 0. So there's the general setup, and we're just going to apply that to this problem here. So very loosely, volume is pi integral big R squared minus little r squared dx. If we apply that to the scenario of this problem, our volume is pi stacked from 0 up to 4. All of our washers or disks are stacking up from 0 to 4 of big R of x squared minus little r of x squared. Now there's a lot of zeros in here, so depending on who taught you, you probably don't have all of those zeros there, and you just have the root x. Root x squared is x, and there's our most simplified expression for volume before we evaluate the integral. And they actually do want us to find the volume, so in this case we could grab our calculator and turn to the calculator to find the value. And so let's do that. If we math 9 to pull up our integral, we are integrating 0 to 4 of the function x with respect to x, and we get the answer 8 times pi. So this is equal to 8 pi. If we are going without a calculator, the antiderivative of x is x squared over 2, which we evaluate from 0 to 4. And that gives us 16 halves minus 0 halves, which is 8 minus 0 times pi. Same problem, just done by hand versus done with a calculator. And since it's calculator active, I always encourage to do integrals and derivatives with the calculator when possible. Okay, and for the points on this one, this is worth 3 points. The first point comes from having the correct limits and the constant of pi. Your second point comes from having the correct integrand, which is x, or maybe you do this expression. And then your third point comes from having the answer correct. So 1, 2, 3. Right. And in part D, we're doing a very, very similar problem as part B. We're finding a vertical line that's going to divide the region so that two volumes are the same. So this is very much the same in the sense that we can use our volume equation, which was x dx, and we're going from 0 to some unknown value k to set up a volume on the left is equal to the volume on the right. And for the sake of brevity, I'm going to take the approach of relying on my answer from part C. Half of 8 pi is 4 pi. It should be noted that that's relying on a past answer, and if you wanted to go without relying on the past answer, you would set this up as an expression like that. So, but we're going to avoid the more, the safer approach for the faster approach. So pi's cancel, and we get the integral 0 to k of x dx is equal to 4, and we work towards solving this. The antiderivative of x is x squared over 2, evaluated from 0 to k is 4. K squared over 2 minus 0 squared over 2 is equal to 4. And then k squared equals 8. K is the square root of 8. So if we move this line x equals k until we are at root 8, we'll have created a volume on the left that is equal to the volume on the right. And this part here is worth 2 points. So your first point comes from, do you have an equation in k? So there's my equation in k, so that's plus 1 point. And then your ninth and final point comes from solving correctly for k. Thanks for tuning in. Again, this was from 1998, question number 1, and it was calculator active. It's a pretty straightforward area volume problem. This dividing the region into 2 spots or into 2 equal halves is a pretty consistent theme that you'll see occurring several different years. So thanks. Be sure to comment, like, and subscribe. Have a good day.